Today we are going to start alcohols, phenols and ether. So let's read from the book. Alcohol, phenol and ethers are the basic compounds for the formation of detergent, antiseptics and fragrance respectively. Means alcohols are used in detergent, phenol used in antiseptic and ethers are used in the fragrance. You have learned that the substitution of one or more hydrogen atom from a hydrocarbon by another atom or a group of atoms result in the formation of an entirely new compound having altogether different properties and applications. Alcohols and phenols are formed when a hydrogen atom in a hydrocarbon, aliphatic and aromatic respectively, is replaced by OH group. First of all, try to understand what is alcohol. When hydrogen of hydrocarbon is replaced with OH. So let's take an example of hydrocarbon. Hydrocarbon can be CH4. So here this is CH4. Carbon which is attached to 4 hydrogen. This is CH4. This is methane. When one of the hydrogen of methane is replaced by OH group. So if I replace this hydrogen with OH, I will get C, here H, H, H and this hydrogen is replaced with OH. So now this becomes methanol. This is methanol. So it is an alcohol. So when we replace one of the hydrogen with OH, you will get alcohol. Similarly, you will get phenol. So let's try to understand what is phenol. So first of all, draw the structure of one aromatic compound, aromatic hydrocarbon. Aromatic hydrocarbon is benzene, which has alternate single and double bonds. So each carbon is bonded to hydrogen. Here there are 6 hydrogen because each carbon is bonded to one hydrogen. C6H6. This is benzene. So when we replace one of the hydrogen of benzene with OH, here I am going to replace this hydrogen with OH. So let's draw the structure. This is benzene where alternate single and double bonds are there. Rest of the positions are occupied by hydrogen. And here I am just going to replace one of the hydrogen with OH. So if I replace this hydrogen with OH, now this becomes phenol. So this is phenol. So aromatic alcohol is phenol. Now let's read from the book. These classes of compounds find wide application in industry as well as in day-to-day life. For instance, have you ever noticed that ordinary spirit used for polishing wooden furniture is chiefly a compound containing hydroxyl group ethanol? The sugar we eat, the cotton used for fabric, paper we use for writing, all are made up of compounds containing OH group. Just think of a life without paper, no notebooks, books, newspaper, currency notes, checks, certificates, etc. The magazines carrying beautiful photographs and the interesting stories would disappear from our life. It would have been a really different world. An alcohol containing one or more hydroxyl groups directly attached to the carbon atom of an aliphatic system. For example, CH3OH that we just have drawn the structure here. It is CH3OH. So this is the formula of methanol. This is CH3OH. While phenol contains OH group directly attached to the carbon atom of an aromatic system. So when you write the formula of phenol, here you will get C6H5OH. So here it is written C6H5OH. The substitution of an hydrogen atom in a hydrocarbon by alkoxy or aryloxy group yields another class of compound known as ether. So here when we substitute hydrogen atom from hydrocarbon by alkoxy or aryloxy group, we will get ethers. So let's draw the structure of one of the ether. So this is hydrocarbon methane, in which there is one carbon which is bonded to 4 hydrogens. Now this time we are going to replace this hydrogen with alkoxy group. Alkoxy group, it can be OCH3. So this is methoxy group. Methoxy. So when we are going to replace this hydrogen with methoxy, you will get the structure HC. It is bonded with another H. It is bonded with another H. And here, this time we have replaced this hydrogen with OCH3. So it is an ether. The name of this ether will be dimethyl ether, as on the both side CH3 group is there. So the name of this compound will be dimethyl ether. You may also visualize ether as a compound formed by substituting hydrogen atom of hydroxyl group of an alcohol or phenol by an aryl or alkyl group. In this unit, we shall discuss the chemistry of 3 classes of compound, namely alcohol, phenols and ethers. Now come to the classification. The classification of compounds make their study systematic and hence simpler. Therefore, let us first learn how alcohol, phenols and ethers classified. Alcohols and phenols may be classified as mono, di, tri or polyhydric compounds, depending on whether they contain 1, 2, 3 or many hydroxyl groups, respectively in their structure as given below. So here first example is monohydric alcohol. As it contains just one OH group, it is called as monohydric alcohol. Now come to the second example. As it contains two OH group, it is called as dihydric alcohol. Similarly, the third compound, as it contains 3 OH group, it is classified as trihydric alcohol. Monohydric alcohol may be further classified according to the hybridization of the carbon to which hydroxyl group is attached. First class is the compound containing sp3 hybridized carbon and OH bond. As in this class of alcohol, the OH group attached to the sp3 hybridized carbon of an alkyl group. They are further classified as follows: primary, secondary and tertiary alcohol. So let's try to understand which are primary, secondary and tertiary alcohol. In these 3 types of alcohol, OH group is attached to primary, secondary and tertiary carbon atom, respectively as depicted below. In the first example, here CH2OH is given. The carbon to which OH group is bonded is this carbon. This carbon is bonded to another alkyl group. As it is bonded to just one alkyl group, this carbon is primary carbon and the alcohol will be primary alcohol. In the second example, this carbon is bonded to another 2 alkyl groups. That's why this carbon is secondary carbon and the alcohol will be secondary alcohol. In third example, here the carbon to which OH group is bonded to another 3 alkyl group. So this carbon will be tertiary carbon and the alcohol will be tertiary alcohol. Now come to the another class of alcohol. This is allylic alcohol. In these alcohol, OH group is attached to sp3 hybridized carbon adjacent to the carbon-carbon double bond, that is to an allylic carbon. As we have learned before, allylic position is the position next to carbon-carbon double bond. As you see in the first example, here CH2 double bond CH, single bond CH2, single bond OH. Here the carbon to which OH is bonded is allylic carbon because it is present next to carbon-carbon double bond. So this carbon is allylic carbon. So this is allylic carbon. As this carbon bonded to one alkyl group, this allylic carbon is primary allylic carbon. That's why the alcohol will be primary allylic alcohol. Now come to the second example. Here, carbon to which OH is bonded. This carbon is allylic carbon. As it is bonded to, here this is one alkyl group and this is another alkyl group. So this carbon will be secondary allylic. It is secondary allylic carbon. And the alcohol will be secondary allylic alcohol. Similarly, in the third example, this carbon to which alcohol is bonded to one alkyl group, second alkyl group, and this is third alkyl group. So this carbon will be tertiary allylic carbon and the alcohol will be tertiary allylic alcohol. Now come to the next class of alcohol. This is benzylic alcohol. In this alcohol, OH group is attached to a sp3 hybridized carbon next to the aromatic ring. For example, OH group is bonded to this carbon and this carbon is just next to the benzene ring aromatic system. That's why this is primary benzylic alcohol. Here when you see in the second example, here OH group is bonded to this carbon and this carbon is next to the aromatic benzene ring. And this carbon is bonded to another two carbons. That's why this carbon is secondary benzylic carbon. So the carbon to which OH is bonded is secondary benzylic carbon. And the alcohol will be secondary benzylic alcohol. Similarly, in the third example, carbon to which OH is bonded, this is tertiary benzylic carbon. And the alcohol will be tertiary benzylic alcohol. Allylic and benzylic alcohol may be primary, secondary or tertiary. Now come to the another class of alcohol. Compounds containing sp2 hybridized carbon and OH bond. These alcohol contains OH group bonded to carbon-carbon double bond, that is to a vinylic carbon or to an aryl carbon. These alcohols are known as vinylic alcohol. For example, CH2 double bond CHOH. Here this OH group is bonded to carbon-carbon double bond. So that's why this position is the vinylic position. This position is the vinylic position. And this alcohol will be vinylic alcohol. Here this carbon is sp2 hybridized because it has formed 3 sigma bond and 1 pi bond. That's why the hybridization of this carbon will be sp2. Now come to the phenols. Phenols also can be classified as mono, di and trihydric phenols. Here for example, this is phenol in which OH group is bonded to benzene ring. Monohydric phenol, as it contains only one OH group, it is called as monohydric. In the second example, as it contains two OH group, it is dihydric. In the third example, as it contains 3 OH group, it is called as trihydric. Now come to the ethers. Ethers are classified as simple or symmetrical if the alkyl group or aryl group attached to the oxygen atom are same, and if they are mixed, they are called as unsymmetrical if two groups are different. Here when you see the example diethyl ether, C2H5O, C2H5. Here oxygen is bonded to two similar alkyl groups. That's why this is symmetrical ether. Whereas in the another example, here C2H5O, CH3. So here oxygen atom is bonded to different alkyl groups. That's why this is unsymmetrical ether. Now let's try to solve this Intext question. Classify the following as primary, secondary and tertiary alcohols. So in the first example, find out the carbon to which OH group is bonded. So this is the carbon to which OH is bonded. First of all, identify the carbon to which OH is bonded. So OH is bonded to this carbon. Now find out how many alkyl groups are bonded to this carbon. So this carbon is bonded to this bigger alkyl group. So means this carbon is primary carbon and the alcohol will be primary alcohol. Now come to the second question. Here CH2 double bond CH single bond CH2OH. Here OH is bonded to this carbon and this carbon is allylic carbon, as it is next to carbon-carbon double bond. And this allylic carbon is bonded to just one alkyl group. Means this allylic carbon is primary allylic carbon. So the alcohol will be primary allylic alcohol. In the third question, the carbon to which OH is bonded is this carbon and it is bonded to just one alkyl group. So again, this carbon is the primary carbon and the alcohol will be primary alcohol. In the fourth question, carbon to which OH is bonded. So this is the carbon to which OH is bonded and this carbon is next to benzene ring. So this carbon is the benzylic carbon. And this benzylic carbon is bonded to one alkyl group and here on this side carbon is also there. So this benzylic carbon is secondary benzylic carbon. So the alcohol will be secondary benzylic alcohol. In the example, carbon to which OH is bonded is this carbon and this carbon is bonded to two alkyl group. Here this is one alkyl group and here this is the one bigger group. So this carbon is the secondary carbon and the alcohol will be secondary alcohol. In the sixth question, here OH is bonded to this carbon and this carbon is next to carbon-carbon double bond. Means this is allylic carbon. And this allylic carbon is bonded to three other carbons. Here these are the two carbons and here on this side this is one bigger R group. So this carbon is tertiary carbon. So the alcohol will be tertiary allylic alcohol. Now in the next video of alcohol, we will learn nomenclature of alcohol, phenols and ethyl.